Good morning, everybody. This is the last portion of your course Marine Engineering. So, I'll give some basic idea about electrical systems used in your shipping or offshore applications. Systems you may have studied already in your first year classes, but still some recapitulation is good for understanding of electrical system or whole marine engineering systems. So, for that you can take any basic electrical engineering book, and or you can go through any website which is relevant to your basic things, basic definition of power, electricity, current. For example, electricity, voltage, power, current, all these definitions you should know actually. Okay, definitions along with unit. For example, I or current, unit is ampere, voltage is current, voltage equal potential, P is power, power unit watt or kilowatt. Okay, similarly you can see resistance, ohm, and other parameters also you should remember. So, voltage and current actually you can compare with hydraulic system or mechanical system. You can see this one circuit is here, one fluid stored here. Okay, atmospheric pressure is here and fluid is going through this. There is one valve and it is going through this valve. Again, control valve is here, then again going back to here, and one pump is working. So, this way fluid is circulating. So, similar way, if you have one electrical source, so electric source, okay, so in that case electricity will be flowing, it will be getting resistance, then there is switch. Okay, again it will be going to back to your electric potential, your electric source area. So, power equals V into I, V equals IR. So, power will be IR into I. So, I square R. Okay. So, this is the formula you should remember. Resistance equals rho L by A. L means conductor length, conductor or wire length. Small l is given there, and area, cross sectional area of this conductor. So, and rho is your electric resistivity, rho is electric resistivity. Okay, unit will be ohm meter. Now, sigma conductance, you see conductance G is formulated as sigma A divided by L, just opposite of rho. Resistance, so sigma is equal to conductance, electrical conductivity, electrical conductivity. Okay, A and L already I defined. So, sigma will be 1 by rho. Okay, N L is the length of the cable. Now, you compare the quantities. Quantity flux, magnetic flux is volume flow rate, and electrical system we say current, and mechanical system we say velocity. Flux density, velocity, current density, stress, potential, pressure, potential, electric potential, and force, mechanical system. So, you should remember how it is matching. So, it will be easier to remember. Maybe if you remember electrical part, you can remember mechanical part. If you remember mechanical part, electrical part also can be easy to remember. And motor synchronous speed, NS equals 1 2 F by P. P is number of poles, magnetic poles are there. F is your frequency, hertz, and motor slip is given here, S equals N minus N2 divided by N. So, this is called motor slip. So, initial theoretical calculated motor N, but when you run motor speed little bit reduced. So, N minus reduced speed divided by original speed. So, original speed minus reduced speed divided by original speed. So, that ratio is called motor slip. So, this is expressed in terms of percentage. So, normally copper wire, copper is having higher conductivity, maybe electrical or heat, both cases copper carries higher amount of heat or electricity, higher heat or electricity. It may not be the highest one, but because of cost and other aspect and your usability, based on that, copper people will be using for electrical conductivity purposes. Either single solid configuration or multiple small strand configuration, multiple small area you take and you wrap it, so that way also it will be used. The stranded cable is mechanical flexible. Stranded cable means, you can see this right side picture. So multiple cables are here, 1 2 3 4 multiple cables, and it will be giving little bit winding, so that way it will work. Braided wire, multiple strand or flexible wire wound on a spool. So for higher amount of current if you are carrying, and insulation is also very important for example marine application. In that case, actually multiple level of insulation will be provided. But in normal application for your let's say household application for electricity bulb fixing, so in that case you do not need so strong cable plus insulation level. But for especially marine and difficult areas where insulation may cause a severe issue, there you use a heavy insulation and carry current. Rated motor torque, HP equals 5250 divided by N. N is motor rated speed, HP horsepower, P equals T omega. I am telling this formula again and again. Conduction, low resistance to electron. Insulation, electric current does not flow freely. Atoms tightly bound in the electrons. So whenever there is a conductor, so there will be one insulator just to protect the conductor. Okay, and especially in shipping applications, any open wire must not be kept anywhere. So semiconductor, electrical resistance between metal and insulator. So semiconductor. Okay, and material, different material will have different your resistivity. So a silver is having a resistivity 1.59. You can see this is a very low resistivity relative to copper also, but silver is not used because it is expensive. Okay, so similarly aluminum also has similar resistivity as copper. Okay, so many other material also will have more or less resistivity, especially uh, copper, silver, gold, maybe those are having lower resistivity, but you cannot use every time because some will have higher cost, some will have some other issues. So normally copper will be common. Some, in many cases, aluminum also used for your electrical conductor. So so inductance. So you have learned all these terms, and inductance and some other terms also there you have to remember. So property of electrical conductor, this is a property of an electric conductor that resists changes in electric current flowing through it. So inductance L equals phi I divided by I. So L is inductance, phi I magnetic flux, and I is your current. Okay. So Faraday law says, Faraday's law. So Faraday, any changes in magnetic field, any changes magnetic field through a circuit induces an EMF, electromotive force or voltage in the conductors. A process is a process called electromagnetic induction. Okay, so this magnetic induction is used in many places. For example, induction motor. For example, your induction heater is there at home, and induction charger. These days, electric vehicle charging or many that wrist watches are there. You don't have to put your cable. Rather, you put on induction surface. So there, it will be automatically charging through induction. Or many places, the scientists are thinking why the road can be placed such inductor, so that whenever car is moving, it will be charging automatically during moving also. So there will be no cable connection, rather through induction there will be charging will be happening. Okay, so here one picture I'll show, not picture, it's video. So you can see actually how electricity and magnetism are linked. So it is for our wave energy system. Wave energy system, we have wave, okay, and we have one floating device. Floating device is having one hole inside, okay, and one rod is coming here, flat rod. It is almost fixed to the bottom. When wave is moving up and down, my buoy is moving up and down. This is buoy, this spar, this is spar, this is buoy, okay. So when buoy is moving up and down, my spar is not moving. So because of that, I am getting relative motion between buoy and spar. So buoy and spar is creating relative motion. Okay, when relative motion is created, you can see this rod is coming out from here. It attached to lots of magnets. Okay, and I have coil here all around. Okay, these are magnets, and this is coil. What is happening when my system is working? You see the video again. Here, when wave is moving up and down, my buoy is moving up and down, my spar is not moving. So I am getting one relative motion. Buoy is moving, spar not moving. So I am getting relative motion between this. Now my spar having some magnets, okay. So the magnets are fixed on spar and coil all around, that is connected to my buoy. So buoy is having connected to coils. So buoy is designed such way it will be fixed with coils, okay, electric coils, and it is having some central hole, and this magnetic rod is coming, and magnets are going through this. So all these are having magnets, the rod. So whenever buoy is moving, my coil is moving up and down, my magnet is fixed, okay, coil is moving up and down, magnet fixed. Because of this one, this coil is getting EMF, electromotive force. So coil is getting EMF. So how to sense? You see the video again, you see this right side, this one, this data digits will be changed when my system is moving. You see this, I am producing electricity here, I can see, okay. So you can see this 3-5 volts, not volt, I think some ampere current it is showing. So when there is relative motion between magnet and coil, we are producing electricity. So similar way, all other electrical system, motor, generator and linear motor, linear generator, those will be designed. Actually, those are getting designed, and this is specific practical application for wave energy converter in Europe and Sweden. Many people has implemented practically. In our laboratory, we have done its laboratory based system. We are trying to scale up. Now, when we are talking about electricity, so you should know the parallel connection and series connection. Here first picture is series, this is parallel connection, okay. So in series connection, all the loads or resistances, resistance mean load, okay, resistance 1, resistance 2, resistance 3, resistance 4, those will be added actually, because see the formula, R equals R1 plus R2 plus R3 plus whatever loads are there. This is EMF you are applying, voltage but in parallel connection the resistances will be inversely connected. For example, R1, R2, R3, three resistances are there and electricity is flowing. Okay, so in that case I have R1 plus 1 by R2 plus 1 by R3 equals 1 by R. Okay, therefore R equals inverse of 1 by R1 plus 1 by R2 plus 1 by R3. Okay, in parallel circuit it is power is calculated like this. We know power equals I square R. Okay, so for R1 power is becoming like I square R equals, for R1 power is current is 5, so 5 square into R value is given 10, so 250 watt. So P R2 I square R2 I2 square R2, so I can say like this, I2 means 2 square into 25, so 400. PR3 we get 50, so total power we are getting PR1 plus PR2 plus PR3 equals 400 watt. Kirchoff's law. So Kirchhoff has two laws. One is voltage law and it's current law. Okay, so Gustav Kirchhoff produced these two laws for conservation of voltage and current. So voltage and current, like let's say I have one node and one current is coming like I1, another current coming I2, another coming I3, and outgoing I4, I5. So this is current out. This is called node. Okay, node. This is a current in. Okay, now as per the current law, I1 plus I2, all current entering into the node and exiting node, total will be 0. So I3 minus I4 minus I5 equals 0. So this is your current law. So one node can have multiple input, multiple output, but total current will be 0. So this is called conservation of current law of current law, and this is current law or first law. Second law it is voltage law or energy law, energy conservation law. So here let's say resistance R1, R, so I have resistances like this, A, B, C, D. Okay, so V voltage A to B across R plus voltage BC plus voltage CD plus voltage DA equals 0. Okay, so the total voltage around a loop, so total voltage around a loop equals the sum of every voltage drop in the same loop for any closed network, and equals to 0. This law called conservation of energy law. Okay, let's say one problem. Problem 4, I think. So let's say R1 equals 2 ohm, R2 equals 4 ohm, R3 equals 6 ohm. Okay, and circuit is like this. Resistance here, then it is coming, another resistance here, then again. Okay, R1, R2, R3, E1 equals 10 volt, E2 equals 5 volt. Okay, so I current you have to calculate. So let's Kirchoff direction law. V equals I R. V equals I R. So minus I R1 plus E1 minus I R2 minus I R3 minus E2 equals 0. So here high to low when source voltage is there, so you take positive, and current when it's going from high to low you take negative. So the values are like this: 2I plus 10 minus 4I minus 6I minus 5 equals 0. Therefore I equals 0.416 ampere. Okay, this is your solution. Thank you very much for today's lecture. Tomorrow we'll continue with this one and we'll finish our marine engineering course. Thank you very much.